Alright, so this is chapter 4.3. We're talking about one-to-one inverse functions. This is Math 108, online version. So we've got inverse functions. We got a function f of g, for which f of g of x equals x for all x in the domain of g, and g of f of x equals x for all x in the domain of f. If we have that, they're called inverse functions. In that case, we can denote that g by f inverse. So what we really look at here is basically you plug one function into the other function. If it gives you an x, you got half of it. Then you reverse it, you plug one function back in the other function. If you get an x there as well, they're inverse functions. And you can call them inverse functions of each other. You can change that g to a f inverse. You could also change that f to a g inverse if you're looking at it from the g aspect. Essentially, what we have here with our example, we've got f of x equals 1,000, or 153,000 minus 1,275x. 153,000 minus x over 1,275 is your g of x. So if we want to do this problem, we can go f of g of x. We're going to plug this function into this function. I get 153,000 minus 1,275 times 153,000 minus x all over 1,275. Now all we have to do is simplify. This cancels this out, so it simplifies to 153,000 minus 153,000 minus x. 153,000 minus 153,000, 0. So we're left with, we got to notice here that we distribute this negative. In doing that, what I get here is a positive x. Be careful of that. Distributing negatives can be tough. But when we do that, what we see here is the 153,000 minus 153,000 plus x gives us an x. Now we're halfway there. We've got to check both. We've got to do g of f of x next and see if it also gives us an x. So I'm going to plug my f of x function into my g of x function. So we'll do 153,000 minus my f of x function here, which is 153,000. And we need to put this in parentheses, minus 1,275x over 1,275. All we've got to do is simplify. Okay, so if I distribute this negative here and here, what I'm going to get is 153,000 minus 153,000, which is a 0. And then I'll get negative, and a negative gives me a positive 1,275x over 1,275. Now, you can see that 1,275 divided by 1,275 is just 1, so we're left with x. We've gotten exactly what we wanted to get right here. We've gotten an x for this one. We've gotten an x for this one. Therefore, we can say that these are inverse functions. So they are inverses. Simple as that. Now we've got our next example. In our next example, it says in order to convert x degrees Celsius to y degrees Fahrenheit, we use the formula y equals f of x, which equals 9 over 5x plus 32. To convert Fahrenheit to Celsius, we use the formula y equals g of x, which equals 5x minus 160 over 9. We need to show that these functions are inverse functions. So we're going to do f of g of x and try to show that that equals x. Then we're going to do g of f of x and show that that equals x. So if we start with the first one, I'm going to start with my f of x function, 9 over 5. My x here is my g of x. So we'll do 5x minus 160 over 9. And then plus 32. We've got to simplify this. So first, what we can do, we notice that this 9 is going to cancel right here with this 9. That's pretty simple. So this 9 and this 9 are going to cancel. I've got a 5 here. So let's simplify this step so we don't get too far ahead of ourselves. We got a 5x minus 160 over 5 plus 32. Okay? We need to distribute this 5 here. 5 divided by 5 is just 1. Leaves me with an x. 160 divided by 5 is negative 32. Negative 32 plus 32, 0. I wind up with x, which is exactly what I wanted. Now, let's do the second step. Second step, we got to come over here. We got to show that g of x, g of f of x equals x. So we'll start with a g of x function. I've got 5 times 9/5. I got to plug my f of x function in right here. X plus 32 minus 160 all over a 9. Okay? That 5 and that 5, pretty easy to see those cancel. I've got a 9x. Alright, I still have to distribute. I distributed my 5 here. I've got to distribute my 5 to this 32. 5 times 32 is going to give us 160. Plus 160. We've got a minus 160 here. All over. Got a 9 here. 160 minus 160 is 0. I get a 9x over 9, which gives me an x, which is exactly what we wanted. F of g of x equals x. G of f of x equals x. Therefore, they are inverses. That's simple. Plug one function into the other, gives you an x, you're halfway there. Plug that other function back into the other function. If that gives you an x2, then you got an inverse function. Alright, so the next thing we're going to look at is one-to-one functions. A function f is a one-to-one function if each output of the function corresponds to exactly one input in the domain of the function. This means there's a one-to-one correspondence between the elements of the domain and the elements of the range. We've got two examples here. It says determine if each of the functions is a one-to-one function. Okay. Easiest thing to do is if you look at it and you feel like it's not a one-to-one function, show an example that proves it's not a one-to-one function. So if we look at f of x equals 3x to the 4th, what we're going to look at here is, okay, what can I plug in here? If I'm thinking about it, what can I plug in here and I get the same answer? Okay. Let's look at 1. If I plug 1 in, 3 times 1 to the 4th. 1 to the 4th is just 1. 3 times 1 is just 3. If I plug in a negative 1, negative 1 to the 4th, negative 1 times negative 1 is negative 1, times another negative 1 is a negative 1. Okay, so negative 1 times negative 1 is a positive 1, times negative 1 is another negative 1, and times another negative 1 is a positive 1. Any negative number raised to an even exponent is going to wind up being positive. So I get a positive 1 times a 3 is a 3. There's not a one-to-one correspondence here because 1 gives me a 3 and negative 1 gives me a 3. So is it a one-to-one function? This one is not a one-to-one function. Now if we look at the other one over here, we can look at it and we say, okay, I've got a cube here. So x to the 3rd minus 1. Alright, so I'm thinking offhand, I say, okay, if I plug in a negative 1 and a positive 1 here, I'm going to wind up with two different numbers. Because 1 to the 3rd is 1. 1 minus 1 is 0. Negative 1 to the 3rd is negative 1. Negative 1 minus 1 is negative 2. So I've got a cubic here. I've got an odd exponent here. And I'm just trying to think off the top of my head if I'm going to wind up with something that's going to wind up being one-to-one, or if it's going to wind up being not one-to-one. Those are your two options. Now coming up next, you can see right below this in your lecture notes, we look at the horizontal line test. That is the easiest way to determine whether something is a one-to-one function or not a one-to-one function. So what I'm going to do, or attempt to do, is I'm going to attempt to bring up my TI-84 calculator on my computer. I'm going to try to attempt to do it in such a way that you're going to be able to see it. So let's bring you right on over here. It's loading. Got the free license. So if it'll ever come up. So what you're going to do on your TI, let's make it a little larger so y'all can see. Okay, so you've got your TI here. You're going to go y equals, you're going to type in the function, x to the third minus 1. Oops. Okay, I'm going to hit the graph button. If I hit the graph button, you can see the graph of it right here. Try to get it where you can see it really, really nice. Okay, what you notice, and what you'll see in this next section, I'm about to read you the definition, is if I drew horizontal lines anywhere on this, it would only hit at one point. Now there's a little area right here where you might have an argument and say, it looks like you might hit a bunch right here. But if you zoom in on that area, which you can do on your calculator, you'll find that you're not going to hit but 1 point at any of them. Okay, it doesn't swoosh high and then back low. It steadily increases. It just does it a lot slower in this area. So because it passes the horizontal line test, then we can say that it is indeed a one-to-one function. Now while I've got you right here, let me go ahead and pull up the definition for the horizontal line test. As you see, it's right there in your lecture notes. A function is one-to-one if no horizontal line can intersect the graph of the function in more than 1 point. So if it passes the horizontal line test, it's a one-to-one function. It also has to be a function before it can pass the horizontal line test. Okay, so it has to be a function. Remember, to be a function, it has to pass the vertical line test. So to be a one-to-one function, it has to both pass the vertical line test and the horizontal line test. So just keep that in the back of your mind. Alright, so I'm going to read it directly from your notes. Inverse functions. The functions f and g are inverse functions if, whenever the pair AB satisfies y equals f of x, the pair BA satisfies y equals g of x. Note that when this happens, f of g of x equals x, and g of f of x equals x, for all x in the domain of g and f respectively. The domain of the function f is the range of its inverse, and the domain of g is the range of f. So, essentially, if you have two sets of pairs and they're opposites of each other, they're inverses. Okay, you see some examples with this on your homework, I promise you. And you'll probably have an example like it on your quiz. It's really, really, really easy. Alright, the next thing we're going to do is find the inverse of a function. So we're going to be giving you a function and you're going to find the inverse of it. We've got a 4-step program for doing so. Okay, it says define the inverse of function f that is defined by the equation y equals f of x. First, we're going to rewrite the equation replacing f of x with y. Second, we're going to interchange x and y in the equation. Third, we're going to solve the new equation for y. Fourth, we're going to replace y with f inverse of x. And we're going to take a note here that if this equation cannot be solved uniquely for y, the original function has no inverse. Okay, so if we look at our example, it says determine whether f of x equals x to the third minus 1 has an inverse function. Okay, it's something we need to determine. I'm going to bring you back to the whiteboard. Okay, get you set back up. So let's write this equation on the board to start with. So we've got f of x equals x to the third minus 1. We want to determine if it's an inverse function. We're going to follow our 4-step program. Remember, the first step says that we need to rewrite the equation replacing f of x with a y. So I'm going to write it y equals x to the third minus 1. Easy enough. Now, it says we're going to interchange the x and the y in the equation. Easy enough. So this was step 1. This was step 2. Step 3 says now we've got to solve the new equation for y. Step 3. Let's solve for y. Okay? That means I need to get y by myself. That means I need to add a 1 to this side and add a 1 to that side. We get x plus 1 equals y to the third. Still got to get y by itself. Okay? So I'm going to take the cube root of both sides. So I'm going to say, okay, I take the cube root here, to get rid of that cube, take the cube root here, then I should be able to get y by itself. So I get y equals the cube root of x plus 1. Okay? Step 4 says replace the y with f inverse of x. Okay? Step 4, we're going to keep it like this. I'm going to go ahead and switch this and put it first. So if you wanted to, you could rewrite it as y equals cube root of x plus 1. Replace this y with the f inverse of x for step 4. Cube root of x plus 1. There it is, folks. That easy. We wound up with an equation. The equation made sense. At the end, we'll show you an example here in a little bit of one that doesn't work out. We're good to go. This is the inverse function of the function that we started with. Simple as that. So moving right on along, it says also note, because each output of f of x corresponds to exactly one input, the function is 1-to-1, thus has an inverse. So next thing that it wants us to do is it wants us to verify that last thing we did. It says verify that g of x equals the cube root of x plus 1 is the inverse of f of x. Now how do we do that? Okay, let's go to the board. We'll show you. Alright, so the original function, remember, was, let's go ahead and write this g of x function now. G of x equals the cube root of x plus 1. That's the one we found. Our original function was f of x equals, I believe, x cubed minus 1. If we want to verify their inverses, we just got to plug each of them into each other and we have to get x. So we got to check f of g of x equals x. So I'm going to plug this g of x function in this f of x function. So I've got the cube root x plus 1. That's my g of x part. It's all cubed minus 1. Okay? So this cancel each other out. I wind up with x plus 1 minus 1, which gives me an x. So I verified the first part. Now I got to verify the second part. G of f of x. Got to verify that equals x. Okay? So I need to take my f function and put it in my g function. So I've got cube root here. I've got x cubed minus 1 from my f of x part. And then I've got a plus 1 right here from the remaining part of my g of x. Okay? Minus 1 plus 1 cancel each other out. I get the cube root of x to the third. Cube root of x to the third is just x. We have verified that we indeed found the inverse of our f of x function with this g. That's simple. Alright, next example says, find the inverse function of f of x equals 2x minus 1 over 3 and graph both f and its inverse. Okay, so write this up on the board real quick. F of x equals 2x minus 1 over 3. Okay, I'm going to move you back here so you can see what's on the board. Alright, so step 1, replace f of x with y. Step 2, we are going to switch my x's and my y's. Step 3, I'm going to solve for y. Okay, that means I need to multiply by 3 here to get it off the denominator. So 3x equals 2y minus 1. I need to add 1 to each side. So I get 3x plus 1 equals 2y. I need to divide by 2 to get y by itself. So I get y equals 3x plus 1 over 2. Step 4, remember, step 4 says that we need to replace y with f inverse of x. So we f inverse equals 3x plus 1 over 2. Now we got to graph it. So bring you right back over here. You might have to bear with me a minute because I've got to bring up the TI and get y'all situated back. Okay, so I'm gonna hold you for a second. We're gonna clear out what we had in here. We're gonna graph it. We're gonna go to y equals. I'm gonna clear out the old. The new is my first f of x was 2x minus 1. That was on top, so I need to put it in parentheses 2x minus 1 over 3. Second, my inverse function I found was 3x plus 1. And that's on top as well, so I need to put that in parentheses. 3x plus 1. And then we're going to divide that by 2. Okay? Let's hit the graph button. Alright, we've got the first function and the second function graphed. You can see it right there. Alright, so looking at those, you're like, okay, am I supposed to see something special? So let's move on along in our lecture notes. Now, what you'll notice is that the graph of a function and its inverse are symmetric with respect to the line y equals x. This is important. That's why we needed to scroll down and read that next part so you wouldn't think I was just pulling something out the air. I'm going to type in on my y3 y equals x. Okay? If I graph this, you'll notice we've got 3 lines. So, I'll move you forward a little bit. Maybe that'll help. We've got the blue line, the red line, and then our y equals x, which is the black line. Now, for them to be inverses of each other, they need to be reflected across that line. Looking at this image here on our TI, it's pretty clear to see that's a pretty good reflection, right? So it's always good to check algebraically because sometimes it can be close and not be the true reflection. But that's pretty spot on there. You can zoom out and check it from a few different angles or a few different window sizes, but those two are inverses. We found it algebraically, we verified it graphically. You can also go back and re-verify by doing f of g of x and g of f of x algebraically if you'd like. Alright, this next part says graph f of x equals x to the third minus 2 and find its inverse and graph its inverse. Well, let's find its inverse and just graph them both together. Okay, so I've got you up here. We've got f of x equals x to the third minus 2. First thing we got to do, replace f of x with y. That was step 1. Second step, we got to switch our x's and our y's. Easy enough. Third step, we got to solve for our new y. Okay, I need to add this 2 to both sides. I get x plus 2 equals y to the third. I need to take the cube root of both sides. So I'll take the cube root of this side, the cube root of that side. So what I wind up with is y equals cube root of x plus 2. Remember step 4, I need to switch y with f inverse of x. We found the inverse. Easy enough. Alright, now we got to graph them. Let's graph and verify. Okay, so get my stand and knock it down so that I can hold you up. Get back to my TI. I'm going to go to y equals. I'm going to clear the first 2 out. I'm going to leave the third in there because that's our y equals x line that they need to be reflected over. So first line was y equals x to the third minus 2. our second one here was the cube root of x plus 2. So if you don't remember where the cube root's at, hit the math button. It's number 4. Cube root of x plus 2. Okay. We hit the graph button. There's the first one, there's the second one. And we have our line y equals x. Now, if you're looking at that, put your square on with it. You can look at it on your own calculator. Remember, blue is our first line, red is our second line, and the black line is our third line, which is the line it's supposed to be reflected on. That looks like they're reflected to me. I believe they are reflected over that black line. Pretty clear to see. If you disagree, you could check algebraically. You could do f of g of x and g of f of x and make sure they both equal x. Now, the next thing that we're going to move on to is another example. So stay tuned. Alright, so this example says if $1,000 is invested for 3 years at interest rate X, compounded annually, the future value Y of the investment is given by Y equals f of X equals 1,000 times 1 plus X raised to the third. To find the interest rate X that results in a future value Y, find the inverse function of f of X equals 1,000 times 1 plus X to the third. B says, use the inverse function to find the interest rate that gives a future value of $1,331 in 3 years. We'll get to part B after we finish part A. So, let's work on part A. Get you set up here. So, we've got our function here. We've got 1,000 times 1 plus X to the third. Let's find the inverse function. Step 1, replace f of X with Y. Okay. Step 2, I'm going to switch my X's and my Y's. Make that X of Y. Now we're going to solve for that Y. That's the first thing we need to do. Divide by 1,000. On both sides. That gives me X over 1,000 equals, these thousands cancel out, 1 plus Y raised to the third. Now remember, to get rid of that, I'm going to take the cube root of both sides. Cube root of that side, cube root of that side. I can distribute this cube root here to this X and to this 1,000. If I do that, cube root of 1,000, think about it. 10 times 10 is 100, times 10 is 1,000. So 3 tens give you 1,000. So what I get is X cube root of X over 10. That's the simplified version. That's going to give me 1 plus Y. I still got to get the Y by itself. Subtract 1 from both sides, so that what I get is the cube root of X over 10 minus 1. Make this a little clearer so you can see it. That equals your Y. Remember, step 4 says that we need to replace our Y with f inverse of X. That's inverse of X equals cube root of X over 10 minus 1. Now, we found the inverse. If you want to verify it by seeing if the original function and the inverse function look like that they're reflected over the Y equals X line, you can. If you want to verify it algebraically by doing f of f inverse of X and f inverse of f of X to see if both give you X, you can. But I think we're good here. We have to answer part B. Remember, part B wanted us to figure out. So remember, part B, you've got it right there in front of you. We've got 1,331. Okay. We need to figure out what our f inverse is when our new X is 1,331. You could plug it directly in this equation. You could say, okay, all I got to do is find f inverse of 1,331, which is the cube root of 1,331 over 10 minus 1. You can plug all that in on your calculator. That's fine. Y'all are capable of doing that. That's a really easy way to do it. However, if if you want to, you can also use the TI in a little bit easier way. So if you go to your y equals here, we're going to do this function. So I'm going to do math to find my cube root function. It's number 4. I'm going to do cube root of x divided by, got to make sure we get on the outside of that root sign, divided by 10, and then minus a 1. I've got it graphed. Now, you got to take in mind here, and I've already kind of adjusted my window some. You've got to take in mind here that the x value we're plugging in is 1,331. So if you go with the standard 10 by 10 viewing window, you're not going to get it. And if you go to zooming out, it's going to take you a while to zoom out to actually see when you have that correct x value. Here, it doesn't look like much. It looks like a flat line right here. Okay, I'm not really worried about the graph. What I'm worried about is hitting the second trace or second calc button and using the value function on the calculator. X equals 1,331. If I hit enter there, it shows me that my y equals 0.01. Okay, so our answer here is 0.01. Don't believe me? We can go back to our regular screen here and we can plug it in just like we had. So we can go math cube root of 1,331. Get outside of that radical sign, hit your divide button. We're going to divide it by 10. We're going to subtract it from 1. Gives you 0.0 or 0.1. So that our answer for B that we'll give is we need an interest rate of 0.01. Red marker's giving out on me. Interest rate of 0.1. Now that's the same thing as a 10% interest rate if you change it to a percent. Either would be fine on a handwritten test. You'll be taking some tests and some quizzes and some homework on Pearson. Pearson's a little bit more picky about how you input things, so make sure that you input it in the proper way. But our answer here, 10% or 0.01. Alright, next part of your note says inverse functions on limited domains. Okay, let's look at y equals x squared. Its inverse is plus or minus the square root of x equals y. This is not an inverse because it's not a function. In order to be a function, it has to pass the vertical line test. Graph that, you'll see that it clearly doesn't. To graph that, you'll have to graph the positive square root function of x and the negative square root function of x. And you'll just notice that it's not a function. Okay, it does not pass the vertical line test. So therefore, it cannot be the inverse. However, if we limit the domain strictly to x greater than or equal to 0, then no horizontal line is going to intersect the graph of f of x equals x squared more than once, because you're cutting that graph essentially in half. So it's going to be 1-to-1, and it's going to have an inverse on that limited domain. Okay, that limited domain is going to wind up being the positive side of the square root of x. Let me show you what I'm talking about. Okay, so I'm going to pick it up. Okay, so what we have here, we've got y equals x squared. And we've got y equals second square root of x. And if you want to look at both sides of it, before we limit the domain, you're looking at the negative square root of x as well. I'm going to do a standard zoom or viewing window. What you see here, here's your function, your original blue function. Okay, your original blue function. Y'all have your red and your black combined to be what would be your inverse function. Like I said, if you drew horizontal lines, this red and black function, which combines to be 1, would not be a function because it does not pass the vertical line test. But, here's the big but here. If we limit the domain of our original function, this blue function here, if we limit it to be strictly greater than or equal to 0, that means we're not looking at this left-hand side of this function right here. Okay, we're just looking at this right-hand side. Now, You say, okay, how does that affect this function right here directly? Well, if we're strictly limiting x to be greater than or equal to 0 on our initial function, remember when you do your inverse function, it's the opposite. So on our inverse function, we would be limiting y to be greater than or equal to 0. So we wouldn't have this black piece. So let me show you what that would look like. Okay, we've got y equals here. That means we wouldn't have this negative one here. Okay, and there's no way I can really adjust this function, but I can adjust the window. Okay, x is strictly greater than or equal to 0. So I'm going to delete this out. I'm going to put my 0 as my x min. Now, your y min here, for your other one, that one's also going to have to be a 0. If you graph that, see what I'm saying? It gets rid of that x on the bottom, or this black part that was on the bottom, and it gets rid of this half of the function here, to where they both, independently or individually, pass the horizontal line test and the vertical line test. So with that limited domain, those are inverses of each other. That's how limited domain works. And you have to be really careful, and you have to watch exactly how the question is worded, or else you'll get limited domain questions wrong, because you'll think that, hey, this doesn't work because it doesn't pass the horizontal line test to be a true inverse, or it doesn't pass the vertical line test to be a true function. An inverse has to be a function to be considered an inverse. So you got a few things to check there. You just have to be really, really careful. Alright, so let's continue on with the notes. No need to stop now. So we essentially did this example. It says we restricted the domain of the original function f of x to x greater than or equal to 0. Then the range of the inverse function is restricted to y greater than or equal to 0. And f inverse of x equals the square root of x defines the inverse function for that case. So we graph on the window, which we did, and we notice that everything's nice and symmetric. Alright, so even if you don't like how I said it, you've got the wording right in there for your notes that'll hopefully help you. So that concludes chapter 4.3. You need to go in, do your MyMathLab homework. If you do your MyMathLab homework, you should be up to par. Alright. Well, also, just so you know, we're doing this new online stuff here because we're all out of school at this moment. So do your online homework. You're going to have a quiz on it. Okay, the way we're going to do the quiz is we're going to take the quiz online. It's going to be the same way you do the homework. The only difference is you're going to be really limited in the time that you can do it. I'm going to give you 2 days to do the quiz. So your quiz is supposed to be on Wednesday. So Wednesday morning at 12:01 a.m. is when it'll open up, and it will stay open until Thursday night at 11:59. Okay. So you got a limited time to take it, okay? You'll be limited to taking it to 2 hours, so you won't be able to take forever in a day to take it. You shouldn't need more than 2 hours to take it. You'll only be able to take it once. You'll probably only be able to log in to take it once, so you can't start it and stop it and start it and stop it. Same thing with your test. This is the very end of chapter 4. Okay, which means we'll have a test on chapter 3 and 4 combined. Okay, so the way we'll do that is through Pearson. Okay, I trust you to be honest and not cheat. It's the best I can do. They've got lockdown browsers that we can make y'all do. They've got things where we can try to record you while you're taking your test. There's ways around all that. It's really not that difficult to do, but because we hadn't set it up throughout the semester, I don't want y'all to have to stress about how to set some of that stuff up. Because technology can be really tricky for some people, and y'all didn't sign up for an online class to begin with. Y'all signed up for an in-class class. So I'm going to trust y'all to be honest and not cheat. So I'm going to make it as simple as I can to access in Pearson. That being said, you will have, same as the quiz, 2 days to take it. You'll have your 2 days. It'll open at 12:01 a.m. the day of the test. It'll close at 11:59 the day after that class period was scheduled. So you'll have a 2-day frame to take it. You will get the 2 hours to take it. you're only supposed to get an hour 50 minutes. I'm going to give you a full 2 hours to take it if you need it. You can't log out and log in. Once you start, you got to sit there and finish it. If your computer does kick off, I think it allows you to get back in. If you struggle with that, please get in contact with me immediately so we can get it figured out. Other than that, you really just got to stay on top of your stuff. If you have any questions at all about the material, email me. I've got webcam material. We can webcam. I can set up Skype. I might still have an account with Skype. I think I could do it with Google. Might even do it with Facebook, depending on whether or not I could do all that. But I can get in touch with you, and if you're stuck on something, let me know. I know this isn't ideal, but we're going to bear with it as best we can. If something didn't make sense in the lecture, like I said, let me know. If you need me to record additional videos, I'll do the best I can. If you don't like something about how I recorded this, it's still kind of new to me. I'm still kind of figuring out what works. Feel free, if you like something a lot, shoot me an email, let me know. If you really hate something, or you say, okay, I have a really hard time seeing this, or I have a really hard time when the camera goes to this angle, let me know so that I can fix it. I watch everything that I upload. I watch way more than one time, but my perspective might be different than yours. I'm going to try to do this where everything's easy to see. Make sure you're downloading your lecture notes. That's where everything will be crystal clear because they're PDFs. I'm doing the best I can to write some of the stuff on the board and to show you a copy on the screen, which can be kind of hard. Other than that, just stay on top of things. Don't get behind, because I'm not going to backtrack and let you do stuff you missed. Okay, it's your responsibility. It's just like we're in regular school. Stay on top of things. Okay, it's up to you. Right, I'm going to do everything I can on my end to have the material up, ready for you to learn. Put my all into trying to show it to you. I need you to stay on top of it. Right, all you got to do is your online homework. You got to do your quizzes and your tests. If you really hate these lecture videos, feel like you've got it all figured out, don't even need to watch them, fair enough. You can go in and do the homework. You understand the homework. You don't have to watch the lecture video. That's fine with me. I just really want you to learn the material and get through it. If you have any questions, let me know. I'm going to wrap it up now. But I hope that we can learn this way and finish out the semester strong. Y'all stay safe, stay healthy, and I'll be seeing you on the next lecture.